Welcome back to the series where I try to explain every element on the periodic table and show off what they're used for. In this video, we will go over elements 71 to 80, from lutetium to mercury. Starting off with lutetium, being the hardest and densest rare earth metal, it doesn't have many uses at all outside of research, as it is rare and expensive. Its main use is to crack petroleum, which is breaking down hydrocarbons in them to refine crude oil into gasoline and diesel as fuel sources. Next, we have hafnium, a corrosion-resistant metal that is great at absorbing neutrons. This makes them great for control rods in nuclear reactors, most commonly found in nuclear submarines. Due to its high melting point of around 2200 degrees, it is also used in plasma arc welding to fuse metals together. Furthermore, hafnium carbonitride is the compound with the highest melting point, up to 4000 degrees. Next, we have tantalum, a metal that doesn't trigger any immune responses in our bodies, making them fantastic for organ implants such as replacing bones. This metal also has a high capacitance, which means that they store a lot of electrical energy, making them great for making capacitors, especially for small electronics. Next, we have tungsten, the metal with the highest melting point at a ridiculous 3400 degrees. Due to this, it is often used in very hot furnaces for metalwork, or alloyed with steel to be used in rocket engines and high-speed cutting tools. It is most commonly used in incandescent light bulb filaments, but it isn't super energy efficient, as more heat than light is generated. Following the metal with the highest melting point, rhenium is the metal with the second highest melting point at 3200 degrees. Similarly, rhenium is used in alloys to make jet engines and lamp filaments. Furthermore, it is also used as the catalyst for hydrogenation, which is adding hydrogen molecules to a reaction, giving us products such as trans fat and high-octane gasoline. Next, we have osmium, the densest element on the periodic table, at around 23,000 kilograms per cubic meter, which is twice as dense as lead. It is mainly alloyed with other metals to make devices where friction wear must be reduced, such as for fountain pen tips and record player needles. Next, we have iridium, which is almost as dense as osmium, but it is the most corrosion-resistant metal that we know of. It is also alloyed with other metals to make things like fountain pen tips, but more interestingly, iridium is alloyed with platinum to make the standard meter bar, which literally defines what a meter is. Speaking of which, platinum is a very rare and expensive metal that is often used in jewelry. However, its most practical use is being a catalyst, reducing harmful emissions in vehicles through catalytic converters, or in the production of nitric acid, silicone, and benzene, which are all materials commonly found in everyday products. Next, we have gold, the most malleable and ductile metal, meaning that it can be easily made into sheets and wires, or shape in general. This is why gold is very valuable in terms of making jewelry, though outside of that, gold is used for computer chips since it doesn't corrode easily, and in heat shields since it reflects infrared radiation well. And lastly, we have mercury, a very toxic metal that is corrosive to the skin and damages your organs. Mercury is used to make thermometers, street lamps, and many other scientific instruments, but they are getting phased out since this metal is quite harmful. And there we have it, those are the elements 71 to 80 explained, from lutetium to mercury. I hope that y'all have learned something interesting today. Thank you for watching, and good luck with everything.